Hello and welcome to our first webinar of the year. This is the 23rd of February 2023. My name is Helen Watty. I'm the Sales Director for Getmapping in the UK, and my colleague Richard Evans, our Technical Sales Specialist, is joining me to present you this webinar. So first, some housekeeping. The format is designed to be sort of more thought-provoking as opposed to sort of a sales pitch. So we're not going into great detail about propositions and that sort of thing. But if you do want some detail on anything, please feel free to contact us. So the format will be a quick introduction to Getmapping, and then straight into some real life examples of where we see solutions being implemented that help attain sustainability and compliance goals for organisations. So in particular, we're focusing on technology solutions that we've seen reduce site visits and therefore reduce carbon footprints. At the end of that, we'll then go into a Q&A where you can feel free to send some feedback online and ask us anything that might have been covered in the webinar or anything else for that matter. So firstly, we want to dive straight into a little bit about Getmapping and what brings us here in front of you with a webinar. We've been around for more than 20 years and we have always focused on our core, which is geospatial. So we are geospatial experts. As such, we keep a very close eye on the market and the trends, and that's why we're here today to talk to you about solutions that we're seeing, market trends that we're seeing as being pertinent to our space, to geospatial and technology. So we were actually the first back in 1999 to create a seamless map of the UK. A seamless aerial map of the UK, and we're the first to actually maintain it as well. So we've maintained that ever since 1999, which is a long time ago now. We were also, though, one of the first companies to stream geospatial data. And of course, geospatial data is very big and bulky, not easy to stream, and we were one of the first to do so. In 2004, we also introduced the first digital camera for aerial capture. So we were the first to really adopt the use of digital technology in that regard. More recently, but still 10 years ago, we were an early adopter of mobile mapping services, so ground-driven LiDAR and ground-driven 360-degree imagery. And we were the first to actually combine that mobile mapping or ground survey data with aerial data as well. Recently, we've launched a technology-enabled, if you like, platform that combines both demand and supply to support on-demand needs for ground, air, and geospatial datasets. So, look, all of that experience today, we're very, very passionate about democratising geospatial data, so making it easier for non-GIS experts to utilise technology, and in particular to utilise technology for sustainability and compliance issues, and to create actionable or automated, if you like, insights. And we're really passionate about providing the right data in the right way. So look, we hope that this webinar will show you how we see that technology underpins everything and that geospatial data and technology sits firmly alongside technology. So it empowers and enhances tech outputs. So we want to help you leverage geospatial datasets. Really, it's all about doing more for less in your own business. And that's what we're going to showcase to you in our case studies here. So on that note, I'm going to hand you to my colleague, Richard, to talk further about how the world has changed and how technology is helping us.
Thanks, Helen. So that's right, the world is constantly changing. It's evolving around us all the time as new technological innovations come into play. And this changes the way that we interact with each other, with the environment, and the way that we live and work. The digital revolution has driven a lot of those changes, though, with the rise of things like smart communications and digital connectivity, allowing us to drastically alter the way that we run our lives. Recently, this has been probably the most evident during the pandemic, where the need to work and communicate with people remotely has meant that more people than ever having to adapt and embrace this sort of new technology in order just to continue to be able to work. This is a sort of a societal shift, and it's very much here to stay as people really do embrace that flexibility of being able to effectively do their jobs without needing to physically go into buildings or go to sites. This transformation as work to work not only benefits individuals and organisations, but also the environment as a whole. But in order to work, it needs to be supported by continuous technological change.
So just to add a little bit to what Richard's just commented on, the ability to combine real world imagery with computer generated information, that's had a major impact, and it provides huge potential for many industries. For example, as we'll see later on, in the highway sector, we're able to for example, use site plans to overlay on actual locations, and technology's had a massive impact on safety for road inspections.
So how can technology help? So the use of geospatial technology has grown in leaps and bounds across all types of industries, all types of sectors over the last few years. And it's used as a tool to understand the environment, but also how the environment has changed. Advanced remote sensing techniques, things like cameras and satellites and other sensors, in conjunction with things like more powerful computer processing ability, has allowed us to create highly detailed digital representations of the world. And better applications and visualization tools in combination with this have allowed multiple users, some of them who are thousands of miles away, to work together in a more collaborative and virtual 3D environment to aid decision making and to drive the world forward, really. Some of the most notable technological advances in recent years have been in artificial intelligence and in deep learning. And the ability for this type of machine learning to identify trends and patterns within the digitized environment can help us identify risks and concerns and opportunities for investigations much, much more efficiently than traditional methods could. And this is without that. So traditional methods are sending out people into the field in teams, and this allows us to make more informed decisions ahead of going into the field for people like planners, for engineers, ecologists on the ground. And technical advances in the way that data is distributed, in particular, ensures the right people have access to the right data so the best decisions can be made, and society and the wider environment as a whole benefits as we work together in a more collaborative way. And as Helen mentioned earlier, the democratisation of data is key to this. It's no good having data locked up in silos and behind firewalls and in project teams. The data needs to be used by multiple people in order to make sure that the best decisions are made to benefit everybody as a whole.
And look, we all know the saying, a picture is worth 1,000 words, and visual intelligence pertains to the fact that we see more in an image than we can actually process ourselves. But with the help of technology, we can pull out those picture concepts and convert the information into meaningful and, as we call it, actionable insights. So now we want to share some real life examples of solutions that have helped reduce site visits and therefore contribute to sustainability goals and compliance goals as well.
So one of the major sustainability steps forward has been the move to more greener forms of energy, in particular renewable energy. So the government has continually pledged to increase the percentage of all power that was generated from renewable sources, and the vast majority of that in the UK obviously comes from things like wind power and from solar. So it's really important to locate the optimal sites for these kinds of power generation. So for wind turbines, for solar farms, and also to understand, which buildings in particular are best suited to be fitted with solar panels. Which is going to yield the most efficient way to generate technology and the highest maximum output. So how can geospatial technology help with this? Firstly, if we look at onshore wind as a starting point. There's a lot of technology in the form of digital topographical modeling. So things like LiDAR and other digital height data sets can help you digitally represent the landscape in a 3D environment, meaning you can start to use 3D modeling in engineering software to understand where the optimal place is for the placement of these wind turbines. Bringing in aerophotography into that can also add another dimension because it shows you what's physically on the ground and whether the actual location is suitable. In the same way, placement of solar panels on roofs is really important. So roofs have to be over a certain size, they have to be orientated in a certain direction and with a certain pitch for solar panels to work correctly. So in order to do this, we can make use of very high resolution aerial photography to actually understand whether that's worth installing on certain places. But if we take this one step further and look at using things like deep learning and AI, we can actually start to computer model and train this technology to understand and identify these roofs before we install the solar panels. So they can tell us things like not only which addresses and specifically which buildings are suitable for solar panels, but also look at things like potential yield, and on top of that, whether there might be any sort of neighbouring sort of structures or vegetation which are going to be detrimental to having the solar panels there because they're creating shadow or something which is going to affect the power. So that's all to do with the placement of technology and the generation of technology. But why you just stop there with using these data sets for that? You can actually use them for other benefits as well. So ecologists, for example, are very keen to ensure that these locations are not detrimental to the environment when installing solar farms or wind turbines. So by using high resolution photography in the same way, we can actually do a lot of the ecological initial surveys from the desktop without the need to go on site, and therefore reduce the overall environmental impact and footprint by quite significant amount. Moving on then to looking at road maintenance in particular. So traditionally, maintaining roads was very costly, very inefficient, quite labour intensive, and it relied, generally speaking, on people, boots on the ground, which is traditional groups of people going out, surveying roads and coming back to report on things like minor cracking and defects, which can be, can evolve into larger problems. Now, the problem with this is obviously there's limited resources to do it. So often the issues of like cracking and so forth can be missed, or by the time people get round to them, they've already developed into larger problems exacerbated by cold weather and heavy traffic. This can lead to things like potholing, which obviously are very costly to rectify and to fix, and can be a danger to road users, can damage property, and can result in road closures as a whole. So how can geospatial data help? So by using modern sensor technology, such as mobile mapping, which you can see here, mobile mapping is vehicle-mounted cameras and other sensors. It's possible to survey very large areas of road, so hundreds of kilometers a day, very quickly and much more efficiently. And this greatly reduces the need for any sort of preliminary site visits or checking, and therefore reduces the overall environmental footprint of such work significantly. So the technology creates effectively a digital environment. It captures a 360-degree panoramic view around the camera, and it also allows, with LiDAR technology, for us to be able to use that within an engineering environment to extract data and measurements and all sorts of things, which means we can actually start to do a lot of the maintenance and a lot of the preliminary prep work without having to send lots of teams of people on sites, meaning we can identify, but go one step further again with machine learning and AI, we can also start to understand where the risks might be occurring and train the information to actually find this cracking and these defects, which can result in the potholes. Similar to the solar and the wind turbine, we can also use this data for other purposes as well. So obviously 360-degree panoramic imagery is ideal for things like understanding where the road markings are, what the condition they're in, what the signage is, other street assets, even ecological and tree surveys can be managed in the same way. So it's all about really sharing and democratizing that data to make it as usable as possible to benefit multiple people.
So we've talked a bit about how, technology can help save footfall, but there's also compliance issues. These are things that used to be something that as an organisation we would think that somebody else has really harsh compliance, and sustainability goals and so on and so forth. But now it's really part of our DNA. Every business now has some form of sustainability, compliance, etc. they need to work to. The water industry is a really good example of where compliance is very, very key. They've, been mandated to advise the public within an hour of an incident or overflow occurrence at some of their CSO sites, combined surge outlets, like the one you're seeing in the picture there. So for the water industry, they've used sort of mechanical sensors to date in order to detect sewage flow, but they still have this big issue of having to advise now the public when there is an issue, and advise them within 1 hour, and advise them in a way that the public can understand. Now, what better way than an image, right? I hear you say. However, having cameras on sites is, that's problematic in its own right, or at least it used to be. Now you can get devices that are static cameras that run on clean power. And they're small devices with very small things like small solar panels, and other clean power devices. But that's just going to resolve one issue. That's going to give you a visual of what's going on with your assets, whether that's your water sewage or whether it's fly tipping, etc. The next thing is the actionable piece. So at the moment, if you put a camera on site, you're going to get all footage coming through all the time, and that needs manpower to actually visually look at, having a person look at footage and see what's going on. But using AI and new technologies like AI, we can now alert the right people to the right data, if you like. So as soon as something changes on this site, for example, as soon as there's water or some sort of fluid, the camera, because it's taking images, maybe on time lapse, for example, would be sent to the cloud, and within the cloud we run AI, and the AI then says, oh, I can see that, and alerts the right person so that we can have an actionable insight that falls out of that. And that not only helps with the mandate to actually advise the public and that sort of thing, but it also does prevent or reduce the amount of times that people have to go on site to check these things. And the same can be said for fly tipping. And we know fly tipping is a massive and growing issue. We all see it in the news all the time. We can go into facts and figures, but if you're interested, give us a call. But finding evidence of who's tipped so that you can discourage them from doing it again by finding them, things like that is very, very, very difficult for councillors and property owners to do. And of course, fly tipping is not only annoying, but it's a blight on the landscape. People living in areas where there's a lot of fly tipping get grumpy with the councillors because the place looks like a tip. But there's also the environment hazard as well. It's the environmental hazard as things rot, and it's just not good. So how do we reduce fly tipping? How do we get better intelligence around an event that's happened and who's done it so that we can prosecute and so on? So now you can have these cameras, that can sit on site and are powered by solar, so they're permanently there, and you can get notified only when a fly tipping event occurs. So unlike in the recent past, where a councillor would have to be assigned to look at footage and trawl through footage. It could take them, days to go through all the footage to see when and if a fly tipping occurrence occurred. Now they can just, be alerted when something happens. Now we have a council who has had massive success reducing the amount of fly tipping by more than 80% at all the sites that they've used cameras at. And what they've done is they move cameras from site to site as well. So when a problem goes away, they can move to a different site, and so on and so forth. So it really, technology, again, it really has helped to reduce the amount of fly tipping. Obviously, having a, geospatial data sets that show you where the most occurrences are happening is useful. Having a map to show, what's surrounding and so on and so forth, and how people are getting in and out of areas where they're dumping, that's all really useful. But having eyes on as things occur and being able to just have alerts for that is also really useful. All of that is combining your geospatial with your platforms, your AI and other technologies. So look, in summary of these real life examples, this has been a small example where technology has enabled adherence to, if you like, compliance requirements in the case of the CSO, combined sewage outlets, and also fly tipping. There's certain compliance requirements that councils need to stick by as well. But it's also aided in our clients' sustainability goals, being able to reduce the amount of footfall. So we've touched on just a few examples here, but the intention of running through some of these real case studies is to have you think about how you can leverage geospatial data sets to do, less in your own business. So do more for less in your own business. So as an example, top left-hand corner there, we touched on aerial imagery as one example, and, we were talking about, Richard was talking about solar energy, and we can use aerial imagery to locate the optimal sites for wind turbines and the like. But further, we can then add AI, like the bottom right, so that we can optimize things like placement and automatically take into account adjacent features and, tall trees or tall structures and that type of thing that will affect output. We also touched on how ground survey work, like mobile mapping, vehicle mounted cameras and other sensors can survey really large areas of roads quickly and efficiently, effectively digitising the environment in a very, very effective way and reducing the environmental footprint significantly. And again, by adding AI, we can extract street furniture, road markings and the like, and we can create really detailed analysis findings and, and quickly and efficiently create extractions and having the right data in the right way. And that's not limited to just one department. So now you can have, a data set, a digitized version of the environment for everybody to use. So for mobile mapping, we're capturing everything the eye can see with our 360-degree imagery, but we're also capturing point cloud, and that's what that image is at the top right. That's not actually a photo, that's actually a point cloud, colorized point cloud. If you'd like to know more, please, by all means, reach out to us. We just don't really have time to explain things in detail here, but we are very passionate about what we do. The bottom left picture is a static camera. So that's an example of one of the devices that we will use for static imagery. And again, we talked about how when you combine that with other technologies like AI, you can start getting actionable, automating a lot of processes and that type of thing. And, all of this is about, obtaining sustainability and compliance goals easier than we did before.
So as Helen said, we've hopefully shown in the examples we've talked through the presentation, the right technology acts as an enabler to allow us to work in a more sustainable way. However, there are other benefits as well that adopting these technologies can have. So one of the key themes that we've tried to focus on through the presentation has been about reducing environmental footprint by replacing the need for traditional sort of walking or boots on the ground survey work with that could be within utility monitoring, asset management, or ecological assessment, with technology that provides actionable insight. So modern high-resolution geographical data sets, such as mobile mapping or aerial photography, which we've talked about, can create a digitized version of the real world. And used in combination with things like deep learning and artificial intelligence, they allow a faster, more efficient and cost-effective way of working. For example, being able to direct a team of road workers to the correct locations for maintenance without having to go out and locate it first, or being able to undertake a preliminary ecological survey without the need to fly somebody to Scotland to check a site for wind turbines. So all of this helps reduce the footprint. So these data sets in themselves, once created, create a permanent snapshot in time of these locations. So this can be shared and used again and again for multiple purposes. So road condition surveys, for example, can be used for parking assessment or tree overgrowth assessment or encroachment or even land use. So there's the thing is what collect once and use many. So again, that reduces the need to go out on site, to do site surveys multiple times, and allows more joined up, collaborative, shared working as a whole.
So to wrap up, what's next? So looking to the future, I mean, we see there's so many possibilities. Billions of people are connected by mobile phones and devices, and there's breakthroughs in fields such as quantum computing and biotech and autonomous vehicles, robotics, and technologies we've talked about like IoT and AI. The possibilities are endless, and already upon us with self-driving cars and, you know, even algorithms that are used to predict our buying habits, and that's just to name a few. So the impact is acceleration of innovation across all industries. That's what we see. A key trend is the development of technology-enabled platforms that combine both demand and supply, you know, to support an on-demand economy. That's what we're seeing. And we're seeing much greater demand for higher quality, higher frequency data sets. So a lot more detail, a lot more current. And that's because AI and machine learning gives rise to, you know, the ability to process data faster and create more accurate patterns and trends, and be able to detect these trends faster. And again, all of that drives the demand for sophisticated and precise data sets. So we also see the combination of sensors, you know, with base maps to optimize things like, you know, combining a base map with to show delivery routes hour by hour, for example, or in our fly tipping example, having a camera on site that then goes to the, you know, sends information to the cloud, to a platform that can manage all of this, and AI that can strip out what's really important to you. We also see digital twins becoming available for more markets. You know, digital twins have been around for a bit, but they're no longer limited to the construction industry or modelling companies. You know, clients are adding non-spatial data and information to these digital models. So having a digital representation of the real world, but in really highly sophisticated ways and detail, and having greater currency. So, you know, being able to have 5 centimetre aerial imagery on an annual basis is something that, you know, is really driving forward a lot of new technology, you know, platforms that we're starting to see come out. So look, we hope that we've inspired you to think about how geospatial technology can help you in your organisation, how to chip away sustainability, you know, by reducing carbon footprints and reducing the amount of physical site visits through the use of technology, and, you know, how we can help meet compliance mandates by providing maps and static cameras, and technology allows you to do things that site visits alone would have done before. And of course, this all culminates in cost effectiveness and business cost savings, and being able to do more for less, and being able to share the data sets across multiple, you know, divisions and departments and so on. So capture once and use multiple times. So listen, we'd love to hear from you. Yeah, please feel free to contact us. We're happy to discuss the possibilities with you further. If you'd like to reach out to us, happy to, you know, go into more detail on anything that might have piqued your interest in this. We're also very keen to hear from you about what you'd like us to talk about. You know, having been in the geospatial industry for more than 20 years, and, you know, being a key provider within this industry, you know, does make us experts in this field. So feel free to tap into that expertise to help you going forward. On that note, thank you very much from both of us, and please do contact us, getmapping.com. Thank you.